Introduction to the cardiovascular system. The cardiovascular system is also known as, aka, the circulatory system. And it includes the blood vessels, and the heart. Where are blood cells produced? The red blood cells, erythrocytes, the white blood cells, leukocytes, and the platelets, the thrombocytes. Where are those produced? This was on a previous video. It is the function of one of the organ systems, not the circulatory system. Some other system has this job, is to make blood cells. So where are those blood cells made? In the red bone marrow, in the spaces of the spongy bone. So it was the job of the skeletal system to make blood cells. Okay, the blood vessels. So this is going to be one of your teaching presentations that you need to be able to teach the difference between arteries and veins. So I'm going to teach that on this video, and whenever you come into the exam assessment, it is possible that you get asked, what is the difference between arteries and veins? That is one of the teaching presentations. And trace the flow of blood through the heart. That is for sure a teaching presentation. Like, everybody in the class needs to be able to, on the first test, trace the flow of blood through the heart. That is an absolute requirement. This heart right here is called the Heart of America, and the atria, okay, this is a 4-chambered heart. Humans, mammals have a 4-chambered heart, also birds. So 4 chambers, you have the 2 atria, the right atrium and the left atrium, and then you have the 2 ventricles, the right ventricle and the left ventricle. Now the atria, which are those little small chambers on top, are just collecting chambers. They just collect the blood. Okay, so the right atrium is collecting the unoxygenated blood from all over the body. And the left atrium, over here, is collecting freshly oxygenated blood straight from the lungs. It comes straight from the lungs to the left atrium. So this is oxygenated blood that will be delivered to all the systems of the body. So they're just collecting blood, while the right atrium is collecting all of the unoxygenated blood from all over the body. The left atrium is collecting freshly oxygenated blood from the lungs. Now the ventricles, those are your actual pumps. Those are the actual muscle chambers that propel the blood with force and pressure, with blood pressure. So the right ventricle is pumping this deoxygenated blood to the lungs, okay, to go get oxygen. And the left ventricle is going to be pumping all of that freshly oxygenated blood to all the systems of the body. So these are the 2 pumps, okay? Now this structure right here between the ventricles, between the right ventricle and the left ventricle, is the interventricular septum. The right side of the heart is considered the pulmonary pump because it is going to pump this blood to the lungs to go and get oxygen. The pulmonary pump, it's pumping the blood to the lungs. While the left side of the heart is considered the systemic pump, because the left side of the heart is going to pump the oxygenated blood to all the systems of the body. Okay, now let's focus on these two big blood vessels, these ginormous, humongous, great, large blood vessels. So these big blood vessels are aorta. Okay, this one is going to be the pulmonary aorta. It's also referred to as the pulmonary trunk. And that is because it's from the pulmonary pump. It's taking this blood and it's going to send it to the lungs. So this is the pulmonary aorta or pulmonary trunk. And then this big blood vessel is the systemic aorta, because it is the one that's taking this oxygenated blood from the left ventricle, the left side of the heart. It's pumping through the systemic aorta all the systems of the body, taking that rich oxygenated blood to all the systems of the body, including the lungs. So this is called the systemic aorta. Now, somewhere along the line, because it is superior, it's like above this pulmonary aorta, it's larger, like longer. So it was referred to as the great aorta. And then just to make it even easier, they just started or like lazier, they just started the aorta. Well, this one is also an aorta. It is a large artery, like a large blood vessel that's carrying blood away from the heart. So they're both aortas. So I kind of have a problem with this one being called the aorta. What about the pulmonary aorta? But if somebody's like saying the aorta, then they're probably referring to the systemic aorta. Okay. So what is the name of this blood vessel right here, this very large blood vessel A? It is the pulmonary aorta or pulmonary trunk. So this is going to be the right side of the heart right here, and that is the side that collects the deoxygenated blood from all over the body and then pumps it from the right ventricle. It pumps it to the pulmonary trunk and then to these blood vessels here, which are the right and left pulmonary arteries. Okay, so from the pulmonary trunk to the right and left pulmonary arteries to go to the lungs to get oxygen. Now, why are these referred to as arteries? Because the definition of an artery is that it carries blood away from the heart. It's going away from the heart. So it's going away from the heart. It's going to go to the lungs. So these are the right and left pulmonary arteries. Now it's going to go to the lungs and it's going to get oxygen. So it's going to come back to the heart via, through the right and left pulmonary veins. So the right and left pulmonary veins bring blood back to the heart. Veins return blood to the heart. So these pulmonary veins, the right and left pulmonary veins, are right here, the right and left pulmonary veins. They are bringing that oxygenated blood to the left atrium, which will then go into the left ventricle, and that will pump the blood, this freshly oxygenated blood, to the systemic aorta, which will go to all the systems of the body, delivering freshly oxygenated blood, highly oxygenated blood under high pressure to all the systems of the body. Now, I also want to mention the superior and inferior vena cava. So while aorta means large artery, vena cava means large vein. So veins, we already said, bring blood back to the heart. They bring blood to the heart. So this is just a large vein. This is a superior vena cava and inferior vena cava. They're bringing that blood back to the heart. They're bringing it to the right atrium. Superior, inferior vena cava. This is something I want you to be able to do, okay? Explain why the pulmonary trunk and pulmonary arteries are colored blue. Why are these arteries blue? So you should have said because they do not have oxygen. Okay, when blood has oxygen, it is a bright red color. So they are colored blue because they're trying to show you that the blood that travels through this pulmonary trunk and pulmonary arteries is carrying deoxygenated blood. It does not have oxygen. It's going to go to the lungs to go get oxygen, and then it's going to come back with oxygen. So these pulmonary veins have oxygen. So this is why they are a bright red. So students, so it throws them off. They get confused. They just can't see it. I always get them. I always get you students on this. I'm like, okay, so what's the name of this blood vessel? And because they're blue, they assume that they are veins, and that is wrong. This is your right and left pulmonary arteries. So the definition of the blood vessel does not have anything to do with whether or not it's carrying oxygenated blood or deoxygenated blood. Okay, the definition of the blood vessel, okay, arteries carry blood away from the heart, so they deal with a lot of pressure, and veins carry blood to the heart, so they do not have a lot of pressure. So these are veins. They are carrying blood to the left atrium. They happen to be carrying oxygenated blood. Okay. I'm going to review the anatomy on this model because the model is backwards. Like we're looking at the back of this heart model. And then I'm going to ask you to name, I'm going to ask you the questions, I'm going to ask you to name these structures. Okay, so let's start with the systemic aorta right here. This is the systemic aorta, or the great aorta, or the aorta. While this big aorta is pulmonary aorta or pulmonary trunk. So if that's the pulmonary trunk, then this is the right and left pulmonary arteries right here that are going to go to the lungs to get oxygen. And then this is going to be the right and left pulmonary veins that's bringing oxygenated blood over here to the left atrium. So this is the left atrium. This is going to be the left ventricle. Okay, and then this blood vessel over here on the other side of the heart, which is the right side of the heart, that's going to be the superior vena cava, and this is going to be the inferior vena cava. So let's see if you were paying attention. Pulmonary veins. So, okay. So over here it is going to be the right and left pulmonary arteries, right and left pulmonary veins. So this is the left pulmonary veins. B is the left pulmonary veins. Systemic aorta right there. Superior, inferior vena cava. So C is the inferior vena cava, and A was the right, left atrium. Okay, now I've kind of went over quite a bit of the anatomy of the heart, and we need to review it because next I have some more anatomy to teach, and then we're going to trace the flow of blood through the heart. So pause the video and answer these questions before moving on. Now we're going to learn the valves. Okay, so there is the AV valves. AV stands for atrioventricular valve. We have the right atrioventricular valve because it's between the atrium, the right atrium, and the right ventricle. So it's right atrioventricular valve, or at right AV valve. It is also known as the tricuspid over here because it has like 3 flaps to it, 1, 2, and then a third one. Now on the left, we have the left atrioventricular valve between the left atrium and the left ventricle. So this is the left atrioventricular valve. Now, it is also known as the bicuspid because it has 2 flaps, and it is also known as the mitral valve. So it has 3 names, kind of like the systemic aorta has 3 names. Okay, the semilunar valves are found between the ventricle and the aorta. So right here between the right ventricle and the pulmonary aorta is the pulmonary semilunar valve right here. Pulmonary semilunar valve because it is found between the right ventricle and the pulmonary aorta. And then over here between the left ventricle and the systemic aorta, we have the systemic semilunar valve, which somewhere, I don't know when it happened, but it started to get the nickname of the aortic valve because this is the aorta, the great aorta, the aorta. So they said this is the aortic valve. Well, what the heck is this? Is this not an aortic valve? Because it's the pulmonary aorta. So kind of like, you know, it's like, I don't like that. I prefer that you say pulmonary semilunar valve and systemic semilunar valve. Give it his full name, okay? But he is also known as the aortic valve. So if you hear somebody talking about the aortic valve, they're probably talking about the systemic semilunar valve, but you might like double check. You might be like, are you talking about the systemic semilunar valve? Because you know there's another aortic valve, which is the pulmonary valve, pulmonary semilunar valve. Okay. Now before we move on from this slide, what the heck is a valve? What do valves do? The purpose of the valve is to prevent backflow. So once the blood flows from one chamber to another chamber, we don't want the blood to go backwards. Okay, so once the blood flows from this right atrium to the right ventricle, we don't want to go back into the right atrium. So this will prevent backflow. It just closes. Okay, then when the right ventricle pumps the blood through the pulmonary aorta, we don't want that blood to come back into the right. We don't want it all to come flowing back. We want it to go forward. So this is going to help prevent backflow. It's going to close and help prevent the blood from falling back into the right ventricle. So the purpose of the valve is to prevent backflow. Now I wanted to show you why the mitral valve is called the mitral valve. It's because of these 2 flaps. It looks like the mitre, which is the hat that the bishops wear. This hat, so it looks just like it. So that's why it was given this name, the mitral valve. Do you have to know all the different names for the valves and for the vessels? You know, like you have the systemic aorta and the great aorta and the aorta. Do you need to know all of those names? Yes. Yes. Yes, you do. Because So if you only learned mitral valve and this physician is talking about the bicuspid, you're going to be like, I don't know what he's talking about. What's the bicuspid? You have to know all the different names that it is called. Yes, I'm sorry, but I'm not responsible for giving the bicuspid 3 different names. But I am responsible for teaching them to you, so you need to know them. Yes, you need to know them. And this is how I'm going to ask you, okay? Because you're like, well, I'm just going to put the one. So when you come into the lab practical and I'm asking you, tell me what is the name of this valve, and you're like, oh, that's easy, that's the left AV valve. And I said, okay, can you give me another name for it? And can you give me another name for it? So yes, I'm going to ask you, what are those names of that valve and the blood vessel? So I'm sorry, but yes, you do have to know it. Okay, now we just got finished learning the names of those valves. So let's pause the video and answer these questions before moving on. Okay, next test question. This is huge. You absolutely do have to tell me this. Like, this is not an option. Many of the teaching presentations, they're numbered like 1 through 10, let's say, and I roll the dice, and whichever number is on the dice, that's the teaching presentation that you're going to teach me. But this one is not going to be numbered. It's just going to be one that you have to know it. So you will be asked to trace the flow of blood through the heart. Okay, you absolutely have to know this for this first test. It's going to be on the test, in other words. Okay, we're going to start with the right atrium, which collects all of the unoxygenated blood from all over the body. And then from here, it's going to get pushed through this structure. What is the name of this structure right here, this valve? The right atrioventricular valve, which is also known as the tricuspid. And then from there, it's going to go into this big chamber. It's going to go into this chamber. What is the name of this chamber? The right ventricle. Okay, so we started with right atrium, collecting all of the deoxygenated blood from all over the body, pushes the blood through the right AV valve or tricuspid into the right ventricle. And then the right ventricle is a pump, and it will pump, it will propel with force. It will propel that blood with force through this structure right here, this valve. Give the name of this valve. That is the pulmonary semilunar valve. And then it's going to go into this big blood vessel. The blood will then flow into this blood vessel, the pulmonary aorta or pulmonary trunk. And then it's going to go through the right and left pulmonary arteries. And then where does it go? So, okay, let's go backward. So the blood is collected, all this unoxygenated blood is from all over the body is collected in the right atrium. And then it gets pushed, it contracts, pushes the blood through the right AV valve to the right ventricle. Then from the right ventricle, it's going to pump and propel the blood through the pulmonary semilunar valve to the pulmonary aorta, to the right and left pulmonary arteries. And it's the pulmonary because it's going to pump it to the lungs, right? So it's going to go to the lungs to go and to pick up oxygen. Okay, so it's going to go get oxygen. Then it's going to come back through the right and left pulmonary veins. And then from the right and left pulmonary veins, it's going to go here. It's going to go to the left atrium, which collects the oxygenated blood, the highly oxygenated blood from the lungs. And then that's going to contract and push the blood through this valve, which is the left AV valve, or the bicuspid, or also known as the mitral valve. And then it's going to go into this chamber, the left ventricle. And from there, it's going to pump with great force, okay, lots of pressure. It's going to pump the blood through this valve, the systemic semilunar valve, which is also known as the aortic valve. And then it's going to go through this blood vessel, okay, the aorta, or the systemic aorta, or the great aorta. From there, it's going to go to all the systems of the body. It's going to deliver highly oxygenated blood under high pressure. So those are the two things that is provided by a 4-chamber heart. So if you had a 3-chambered heart, it would not be delivered. 3-chambered is not going to be highly oxygenated, okay? And if it's 2-chambered, it's not going to be under high pressure. So it doesn't, 4-chamber heart is important because that design supplies highly oxygenated blood under high pressure. So these are the two things, okay? These are two things. And this is what our nervous system and our heart requires. For our nervous system to completely develop or to survive, and our heart, that muscle of the heart is extremely demanding. It requires highly oxygenated blood under high pressure, and so does the brain. So these two systems, these two organs are really demanding. They have to have highly oxygenated blood delivered under high pressure. And if one of those is missing, if you're missing the oxygen or you're missing the pressure, those cells will die. The neurons will die. Your cardiac muscle cells will die without oxygen or without pressure. So you have to have those two things, like always. Oxygen, highly oxygenated blood delivered under high pressure. So those are like two really important factors that the 4-chambered heart provides. Okay, from there, you're going to say, on venous return. On venous return means now you're coming back to the heart, okay? You went to the cells, you delivered all this freshly, highly oxygenated blood under high pressure, and now you're coming back to the heart. So it's going to come back to the superior and inferior vena cava, and it's going to come back to the right atrium. Okay, so you might be a little bit overwhelmed. You're like, oh my God, I have to learn all that. Oh my God. Yes, you do have to learn all that. So we're just going to review it again. Okay, trace the flow of blood through the heart. Repetition is the key to learning. So you just keep going over it and over it and over it and over it until you learn it. And I need you to learn it. Like, you can't pass anatomy and physiology if you do not know how the blood flows through the heart. Like, I'm not going to let you pass. Like, you're going to fail. Okay, so I need you to learn this. It's important. So right now you might be like, it's too much. I can't learn it. Woe is me. Okay, we're going to learn it. Okay, we're going to keep going over it and over it and over it until you do learn it. And then we're going to learn it again. And then we're going to learn it again. And then we're going to learn it again. Okay, you have to learn this. All right. If you don't learn anything at all. Okay, all right. So right here, right atrium. is where we're going to start. We're going to start with the right atrium, collecting all the deoxygenated blood from all over the body. And then it's going to go through this valve. What was the name of that valve? It's going to be the right AV valve, right atrioventricular valve, or also known as the tricuspid. Okay, and then it's going to flow into this chamber right here. What is the name of this chamber? That is going to be the right ventricle. And then from the right ventricle, it's going to pump the blood through this valve, which is going to be the pulmonary semilunar valve. And then it's going to go through this blood vessel, which is the pulmonary aorta. And then it's going to go through the right and left pulmonary arteries. Okay, so right atrium, right AV valve, right ventricle, pulmonary semilunar valve, pulmonary aorta, right and left pulmonary arteries to the lungs to go get oxygen. And then it's going to come back through the right and left pulmonary veins to the left atrium. So the left atrium collects oxygenated blood from the lungs. Right atrium collects deoxygenated blood from all over the body. Left atrium collects oxygenated blood from the lungs. So we went from the pulmonary aorta, right and left pulmonary arteries to the lungs to go get oxygen. And we're coming back through the right and left pulmonary veins, which now are carrying oxygen, to the left atrium, collecting all that oxygenated blood from the lungs. Then it's going to go through this valve. What is the name of this valve? The left atrioventricular valve, or left AV valve, or bicuspid, or mitral valve. So left atrium to left AV valve to this chamber, the left ventricle. And that is going to propel the blood with high force through this valve right here, the systemic semilunar valve, or the aortic valve. And then it's going to go into this blood vessel, which is the systemic aorta, or the aorta, or the great aorta. And then where's it going to go? From the systemic aorta, where's it going to go? It's going to go to all the systems of the body. Okay, so let's go back. Right atrium, right AV valve, right ventricle, pulmonary semilunar valve, pulmonary aorta, right and left pulmonary arteries to the lungs to go get oxygen. Then it's going to come back, right and left pulmonary veins to the left atrium. Left atrium collects all that unoxygenated blood from, what am I saying? Now I'm lost. It collects all of the oxygenated blood from the lungs. And then it's going to go to the left AV valve, to the left ventricle, to this systemic semilunar valve, to the systemic aorta, to all the systems of the body. And that's going to deliver what two things? Highly oxygenated blood delivered under high pressure. And then you're going to say, on venous return, it's going to come back to the heart through the superior and inferior vena cava, back to the right atrium. Okay. It's kind of like faded. You can't see it. Okay, so you're going to go follow the arrows. Right atrium. Right AV valve. Right ventricle. Pulmonary semilunar valve. Pulmonary aorta. Right and left pulmonary arteries. To the lungs to go get oxygen. Then it's going to be right, they don't have the right, and left pulmonary veins to the left atrium, to the left AV valve, to the left ventricle, to the systemic semilunar valve, to the systemic aorta, to all the systems of the body, delivering highly oxygenated blood under high pressure. To all the systems of the body. On venous return, it's going to come back to the superior and inferior vena cava, back to the right atrium. Okay, so right now I want you to pause this video and I want you to practice tracing the blood through all of these structures. How am I going to ask you this on the test? It's going to be a live video exam assessment. Okay, so we're going to be meeting like a video chat, and I'll probably ask you close your eyes and start with the right atrium, and you're just going to say it. You're just going to say it all the way through. And then on the lab practical, I will have pictures of the heart models, and that's where I'll ask you, what's the name of this, what's the name of that, what's the name of this valve, what's the name of this. And that will also be a live video exam assessment as well. So I will be watching you as you're looking at the model that I'm displaying to you, where I can watch you in your video while I show you this picture, and then I'll say, hey, what's the name of this valve, and you're just going to answer it like that. So everything is like live video. Okay, so you have to learn this. You have to. All right, now let's talk about lub dub. Let me just kind of quickly review this model real quick. So here we have right atrium, right atrioventricular valve, right ventricle, pulmonary semilunar valve, pulmonary aorta, systemic aorta, superior vena cava, left atrium, left ventricle, left atrioventricular valve. Okay. All right, so now you know how to trace the flow of blood through the heart. Excellent. Okay. So next, let me explain how it does it. Okay, so you have the two pumps. You have the right pump sending blood to the lungs, and you have the left pump sending blood to all the systems of the body, and they are working at the exact same time. So while the right ventricle sends blood to the lungs to go get oxygen, the left ventricle is sending oxygenated blood to all the systems of the body. So your two atria contract together, and then the two ventricles contract together. So you have the two pumps are going to two different locations. Right is going to lungs, left is going everywhere else, all systems of the body. including the lungs. It has to deliver oxygenated blood to the lung tissue as well. But you have them both pumping in different aortas, okay, different locations, but they're pumping at the same time. So the atria contract together, then the ventricles contract together. So when you listen to the heart, you hear that sound, lub-dub, 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 lub-dub. Lub is the closing of the AV valves, the atrioventricular valves. So after the atria contract and push the blood into the ventricles, those AV valves close to prevent the backflow. So you hear lub. Then the ventricles contract to propel the blood to the lungs and to the systems. So dub is going to be the closing of the semilunar valves, because after the ventricles contract, it goes through the semilunar valves. The semilunar valves close to prevent backflow, to prevent the blood from going back into the ventricle. So lub-dub, lub-dub, lub-dub. That is the sound of the closing of the valves. Lub is the closing of the AV valves, and dub is the closing of the semilunar valves. Now, what if you were to hear lub, sh, dub? Like you're listening with your stethoscope, you're auscultating with your stethoscope, and you hear lub, sh, dub. Okay, sh is not something you're supposed to hear. That is backflow. Okay, if you hear a turbulent backflow of blood, lub, sh, dub, that means you're hearing blood flowing backwards. And that is a problem with one of your valves. Which valve is faulty if you hear lub, sh, dub? So lub is the closing of the AV valves. But if you hear lub, sh, dub, that means that one of those AV valves is not closing all the way and you're hearing backflow. So lub, sh, dub means there's something wrong with one of the AV valves. What about lub, dub, sh, lub, dub, sh, lub, dub, sh? What's the problem? So dub is supposed to be closing the semilunar valves. So if you hear lub, dub, sh, that means one of those semilunar valves is not closing all the way and blood is flowing backwards, and you're hearing it when you hear sh, lub, dub, sh. You're hearing the backflow of the blood from the semilunar valve. One of those is not closing correctly or completely. What if you heard lub, sh, dub, sh, lub, sh, dub, sh, lub, sh, dub, sh, lub, sh, dub, sh? Okay, you're all kinds of messed up. You got all kinds of valve problems. You got a valve problem over here, a valve problem, AV valve, semilunar valve. Oh my goodness, you're messed up. All right, now this model is very accurate because it does demonstrate the correct sizes. Let me ask you, the right side is pumping the blood to the lungs. The left side of the heart is pumping the blood all the way to your pinky toe, to your pinky finger. It's pumping oxygenated blood to all the systems of the body. So which ventricle needs to be stronger? Does the right ventricle, which just pumps it to the lungs, or the left ventricle that pumps it to all the systems of the body? Which one has to be stronger? So the left side has to be stronger because it's pumping to all the systems of the body. So this is, the left side has a thicker wall of a thicker layer of myocardium, So this muscle right here, this heart muscle, the myocardium, is a lot thicker on the left side than on the right side. And because it is so much thicker, because it has to be so much stronger, it causes the heart to lean to the left. So your heart is right behind the sternum, but it does lean a little bit to the left because that left side is so much thicker and it's got a much thicker layer of muscle. So this one's accurate. The apex is just a little pointy. The heart is considered to be shaped like a cone, and the apex is this little tippy part of the cone. This is the apex of the heart. What was the name of the serous membrane around the heart? What was the name of the serous membrane around the heart? The pericardium. And remember that it has a visceral layer that is attached to the heart, and then it has the parietal layer that is not attached to the heart, and between them is serous fluid so the heart can beat in this friction-free environment. The epicardium is the outer layer of the heart. So the epicardium is actually the visceral pericardium. Like, it's the exact same thing. So epicardium is just another name for that outer layer of the heart, which is the visceral pericardium. That is the layer that is attached to the heart. Next, the difference between arteries and veins is going to be another test question. Arteries, the definition of an artery is a blood vessel that takes blood away from the heart. And since it's going away from the heart, it's dealing with a lot of pressure. So that ventricle that is pumping on the left ventricle, it's pumping with high pressure. You know, your pressure is like 120/80. So that pressure is like 120, or higher, especially if you're like exercising. So it's something like 100 millimeters of mercury. These blood vessels are dealing with a lot of pressure. And when you look at their anatomy, the arteries are round and they have very thick walls, or you could say layers. They have a lot thicker, their layers. And the arteries are only found deep in the body, like up alongside the bone, deep, to be protected by the skeleton, by the bones. Veins are the blood vessels. Okay, the definition of a vein is a blood vessel that brings blood back to the heart. It brings blood to the heart. Okay, returns blood to the heart. So it's not dealing with a lot of pressure. The most pressure a vein is dealing with is 10 millimeters of mercury at the most. So very little bit of pressure. And because of that, the vein is floppy. It's not nice and round. It's just kind of floppy. It doesn't have any pressure, keeping it like open, like really round. And it has thin layers. The walls are very thin in comparison to the arteries. And veins are found deep, but they're also found superficial. So you have like these accessory veins that are helping to return blood back to the heart. So those are the vessels that you see just beneath your skin here. Those are your veins, the ones that you can like see them because they're superficial. So that is the difference of arteries versus veins. Does in that definition, in this, did we say anything about oxygen? No, because that does not define. What if you're like, you don't have any oxygen? That is not the difference between an artery and a vein. Okay, that's not the difference. Okay, remember the pulmonary arteries, pulmonary veins. Okay, so we're not going to say anything about whether, it carries oxygen, doesn't carry. No. That's not what defines. That is not what defines an artery from a vein. Okay, it has to do with carrying blood away from the heart and dealing with pressure and bringing blood back to the heart, and you have pretty much like no pressure. So anatomically they are different. Okay, so aorta means large artery, and then we have the artery, which is kind of like a medium-sized blood vessel, and then we have arterial. Arterial is small artery, like a little bitty artery. And then you're going to have the capillary. And it is at the capillary where you have the exchange of nutrients for waste. So when the blood is traveling through the aortas, the arteries, the arterioles, it's just traveling through those blood vessels. It's just traveling, it's being carried. It is not until you get to the capillary where the blood actually interacts with the cells. So capillary is where all the action is at. Okay, that is where everything happens. That's where the nutrients and the oxygen are delivered to the cells, and you pick up in the capillary, pick up the waste, carbon dioxide from the cells. And so then you're going to be on venous return because you already delivered the oxygen and nutrients to the cells. Now you're going to return all that waste and back to the blood is going to be returned back to the heart. It's going to be on its venous return. So a venule is like a very small vein, and then you have the vein, which is like a medium-sized vein, and then you have the vena cava, which is superior inferior vena cava, which means large vein. And the stuff that is flowing in your blood vessels is referred to as blood. Okay, and if you exclude the blood cells, it's referred to as plasma. So the blood minus the blood cells is the plasma. But when that fluid from the plasma flows out of the capillary and moves into the tissue, it's referred to as interstitial fluid. It's the exact same fluid that was the plasma. Okay, it's the same fluid, but it's moving out into the tissue space. It's referred to as interstitial fluid. Now, every day, what happens is you're pushing more fluid out than you're pulling it back in. So over here at the arterial end, we have a blood pressure of 30 millimeters of mercury at the beginning of the capillary, but we only have 10 millimeters of mercury at the end of the capillary. So there's more pressure pushing this fluid out than pulling it back in. And what happens is every day, everybody suffers from a little bit of edema. So think about it, like in the morning when you wake up, you have really skinny fingers and your rings fit on your fingers easily, but you've been working all day, you've been doing stuff all day. By the end of the day, you got fat fingers and your feet are swollen and your clothes feel tight, your shoes feel tight, your socks feel tight, your rings, you can't take your ring off because you're swollen. So everybody every day does develop a little bit of edema because there's more of this fluid coming out than getting pulled back in. But then through the night, the lymphatic system works to return all of that extra interstitial fluid back to the blood. So in the night while you're asleep, let's hope 6 hours, 6, 7, 8 hours, the lymphatic system is busily returning all that extra interstitial fluid back to the blood. So then when you wake up in the morning, you're skinny again. You're much skinnier. You're not swollen. Okay, what else I want to say is this is that 10 millimeters of mercury. That is the highest pressure returning blood to the heart. So veins have such very little pressure to return the blood to the heart, very little. Okay, now let's Pause the video and review. Again, pause the video and review. And that concludes the video introduction to the cardiovascular system.